Morning students, last class we have discussed about the chatelier principle, where if we change any of the factor that determine the equilibrium condition of a system, will cause the system to change in such a manner so as to reduce or to counteract the effect of the change. If we are changing any type of factor there, so then the reaction will be, or the system will be changing itself in such a manner that the increased one or decreased one or change one we can counteract, or we can reduce, we can say, means balanced, we can say. Now we are coming for the, already we have discussed about the effect of concentration change. Today we will discuss about the effect of concentration, and here we have discussed about the, I think, effect of concentration change already have discussed, and one more is coming about the an experiment we have to discuss now. Okay, what is the experiment here? Now when iron react with thiocyanate, this is called thiocyanate, SCN minus. So it is forming the iron thiocyanate. Okay, so ferrous thiocyanate is forming here. So now this color is deep red. You can see that one. This is yellow color. This is colorless. This is deep red. So when it reaches equilibrium, at that time, what you can see, the deep red will appear, and after some time, the deep red intensity of the deep red will not be changing now. Means first at the beginning of the reaction, the deep red will be, intensity will be now increasing, and then when it reaches equilibrium, the deep red become constant, means there is no change in the deep red. एक particular deep red आपको मिल जाएगा. So now suppose if we are adding three conditions are there. So if we are adding, means suppose we are adding here oxalic acid. What is the formula of oxalic acid? Now H2C2O4. If we are adding the oxalic acid, it reacts with which one? Fe3+. तो जब भी रिएक्ट्स हो जाएगा ऑक्सैलिक एसिड के साथ, तो Fe3+ विल बी रिड्यूसिंग फ्रॉम द सिस्टम में क्या हो जाएगा, Fe3+ जो था वो ऑलरेडी ऑक्सैलिक एसिड के साथ रिएक्ट कर लिए, तो Fe3+ के अमाउंट क्या हो जाएगा, कम हो जाएगा. तो टू बैलेंस दैट सिचुएशन, टू काउंटरैक्ट दिस सिचुएशन, द नाउ सिस्टम विल बी coming in reverse direction. Why? Because in the reverse direction, the ferrous thiocyanate will be distributed into or dissociated into iron and ferric and thiocyanate. Okay, so now in that situation, by reversing the direction or reversing the reaction, we can get the ferric ion there. Okay, so when we are getting the ferric ion, then that means when by adding the oxalic acid, this is the oxalic acid H2C2O4, when we are adding with Fe3+, this oxalic acid is forming one complex with the, we can say, the iron. So this ferric ion will be reduced from the system. So now to make the iron increase, how to increase? Now then the reaction will be proceeding in reverse direction to dissociate into iron, ferric ion and thiocyanate. So definitely the amount of the ferric ion which was reduced, that again counteract by which one? By reverse direction. So now decreasing the concentration of free Fe3+, in accordance to with the chatelier principle, what is coming here? Now the concentration stress of removed Fe3+ is relieved by dissociation of the ferric thiocyanate to ferric ion and thiocyanate ion. Okay, so this is the first condition. Second condition, what is happening now? If we are adding the mercury chloride, HgCl2, also decreases the red color. So when we are adding the oxalic acid, what is actually happening there? Now red color of this ferric thiocyanate will be decreasing. Why? Because this ferric thiocyanate is now dissociating into ferric ion and thiocyanate ion. So definitely it is dissociation when happening, so this deep red color will be decreasing, intensity of the red color will be decreasing. And when you are adding the mercury chloride जब हम add कर रहे हैं, at that time also we can see that deep red color also will be decreasing. Why? Now this mercury is reacting with which one? Mercury is reacting with the thiocyanate, and they are forming the complex with mercury thiocyanate there. And तो definitely जब mercury thiocyanate के साथ रिएक्ट हो गए, तो डेफिनेटली थायोसानेट रिएक्शन सिस्टम से क्या हो गया, रिमूव्ड हो गए, मीन्स अमाउंट कम हो गए. तो दिस अमाउंट विल बी इंक्रीजिंग बाय अगेन रिवर्स रिएक्शन, मीन्स व्हेन द फेरिक थायोसानेट इज डिसोशिएटिंग बाय रिवर्स रिएक्शन, then it is dissociating into thiocyanate, means again this thiocyanate which was removed from the system by mercury chloride, again it is compensated by this reverse reaction. So now the reaction will be proceeding in direction of left, means reverse reaction will be working there. And if we are adding the potassium thiocyanate, means if in the system we are adding the thiocyanate ions there. So at that condition we can see the potassium thiocyanate if you are adding, then again the reaction will be increasing in which direction? Forward direction, and the deep red color will be increasing, intensity of the color will be increasing there. So when we are adding either iron or thiocyanate, so definitely it will be increasing in forward direction. But if we are adding some substances which can remove the iron or thiocyanate, just like the first we are adding the oxalic acid, then iron is removed from there. If we are adding the mercury chloride, the thiocyanate removed from the system. So when the amount is reducing, if by adding any substance there, so at that condition, to balance it or to compensate that one, to counteract that reduction, so the reverse reaction will be working there. So this is called the chatelier principle. If we change any factor in a equilibrium condition of any reaction, so that reaction will be proceeding in that direction where this change will be counteract. Okay, अगर आपने amount decrease कर दी, नंबर ऑफ एटॉम डिक्रीज कर दी, सो डेफिनेटली नंबर ऑफ एटॉम इंक्रीज होगा, जिस डायरेक्शन में उसी डायरेक्शन में रिएक्शन प्रोसीड होगा. इफ वी आर एडिंग द मोर अमाउंट ऑफ आयरन देयर, सो दिस आयरन को बैलेंस करने के, काउंटरएक्ट करने के लिए क्या होना चाहिए, जहाँ पे ये इंक्रीज आयरन एब्सॉर्ब हो जाएगा, दैट मीन्स द फॉरवर्ड डायरेक्शन में द रिएक्शन विल बी गोइंग ऑन. ओके, so this is about the concentration. Next we are coming for the effect of pressure change. Just like one example is given to us, here it is coming CO plus 3H2, production is coming here CH4 and H2. Here what is coming now? 4 mole of gaseous reactants. Here 3 mole and 1 mole. What is coming here? 4 mole. So 4 mole of gaseous reactant producing the gaseous product. How many are there? 2 mole of gaseous products are producing there. Mole always directly proportional to partial pressure. That means pressure is decreased here, क्योंकि यहाँ पे 2 मोल है, यहाँ पे 4 मोल है, तो pressure is increased here. तो suppose if we are increasing the pressure, that means the reaction will be going in forward direction, so to reduce the pressure. Clear? And if we reduce the pressure, it will be coming in backward direction to increase the pressure. So one thing we are discussing here, the direction in which, suppose we can see here, the direction in which the reaction goes to re-establish equilibrium can be predicted by applying the chatelier principle. So since the pressure has doubled, the equilibrium now shift. Suppose we are here, it is given the total pressure will be doubled, है ना. अगर टोटल प्रेशर आपने डबल्ड किया तो अभी क्या हो जाएगा ना, प्रेशर जहाँ पे रिड्यूस होगा उसी डायरेक्शन में दैट, क्योंकि प्रेशर ने अपने इंक्रीज किया रिएक्शन सिस्टम में, तो डेफिनेटली जिस डायरेक्शन में प्रेशर डिक्रीज होगा उसी डायरेक्शन में द रिएक्शन विल बी प्रोसीडिंग नाउ. सो सिंस प्रेशर हैज डबल्ड, दैट इज द आंसर हियर, सिंस प्रेशर हैज डबल्ड, the equilibrium now shifts in a forward direction, a direction in which the number of moles of gas of pressure decreases. So we know that pressure is proportional to the moles. Already I told that one, कि number of moles is directly proportional to pressure there. So if we increase the pressure in the system, so we have to proceed, the reaction will be proceeding in that direction where the pressure is decreased. क्योंकि आपने increase किया तो pressure को increase pressure को क्या करना है, balance करनी है, counteract करनी है, तो definitely जहाँ पे pressure decrease हो रहे उसी तरफ, उसी direction में the reaction will be proceeding. So now if we are increasing the pressure, as it is 4 mole in reactant and 2 mole in product, so definitely the pressure is high in the reactant side and pressure is low in the product side. So definitely the reaction will be proceeding in forward direction to balance the increased pressure there. Okay, next one we are coming here in case of QC also, you can see the when it is coming QC is less than KC, means when we are increasing the pressure, so where the pressure is increased, here the pressure is increased. So in case CH4 means CH4, it is coming about the CO and 3H2, तो यहाँ पे pressure increase हुआ, means यहाँ पे pressure increase हुआ, तो जब यहाँ पे pressure increase हुआ तो QC is coming less than KC now, क्योंकि यहाँ पे डिनोमिनेटर बड़ा हो गया तो डेफिनेटली QC कम आ जाएगा, तो QC is coming less than KC, so definitely in that condition the forward reaction, the reaction will be proceeding in forward direction. Next is coming inert gas addition, effect of inert gas addition. In that condition, if that volume is constant, so by adding the inert gas, will be no effect there. It is because the addition of an inert gas at constant volume does not change the partial pressure. क्योंकि वो react करता ही नहीं, inert gas है, तो reaction जब तक नहीं होगा तब तक partial pressure में कोई change नहीं आएगा. So partial pressure or the molar concentration of the substance involved in the reaction. So जब तक partial pressure या molar concentration is not changing, so definitely the reaction equilibrium also will not be changed there. So if we are adding the inert gas in a system and they are in a constant volume, definitely the volume must be constant, then it will not change any partial pressure or any molar concentration. So definitely it will not create any effect there. Now we are coming for the effect of temperature change. So definitely if you are considering one reaction, suppose this is the reaction, N2 plus 3H2, what is coming here? 2NH3 and delta H means enthalpy, reaction enthalpy is coming here minus 92.38 kilojoule per mole. So minus 92.38 means, what does it mean? The enthalpy is or the energy is released. That means energy is coming along with the product. Clear now? So we can write down N2 plus 3H2 is converting into 2NH3 plus energy, heat energy you can say. So when suppose if we are providing, this is an exothermic reaction. So in an exothermic process, according to the chatelier principle, if we are increasing the temperature, मान लो अपने सिस्टम में टेम्परेचर को इंक्रीज किया, सो डेफिनेटली इन टेम्परेचर डिक्रीज किस तरफ होगा ना, इफ वी आर कमिंग इन बैकवर्ड डायरेक्शन, बिकॉज टेम्परेचर इज हियर. तो इफ वी आर इंक्रीजिंग द टेम्परेचर, डेफिनेटली इट विल मेक द डायरेक्शन ऑफ द रिएक्शन टुवर्ड्स बैकवर्ड टू डिक्रीज द टेम्परेचर. तो टेम्परेचर यहाँ पे कम है, यहाँ पे ज्यादा है. तो यहाँ पे लिखा है कि लाचटलियर प्रिंसिपल, रेजिंग द टेम्परेचर शिफ्ट्स द इक्विलिब्रियम टू लेफ्ट एंड डिक्रीज द इक्विलिब्रियम कंसंट्रेशन ऑफ द ammonia. So when it is coming towards left, so definitely concentration of the ammonia will be decreased there. That means in exothermic reaction, if we are increasing the temperature, definitely the reaction will be coming in backward direction. In endothermic reaction, where the reaction energy or heat is providing along with the reactant, so if we are providing the temperature, increasing the temperature, definitely it will go in forward direction. ये है according to Lachatelier principle. One example is given to us. What is the example? Now NO2 is converted into N2O4. Okay. And what is the enthalpy? It is an exothermic reaction because enthalpy is released minus 57.2 kilojoule per mole. Okay. So here you can see, this is the figure is given to us. Here two test tube we are taking here. Two test tube we are taking here 3 beaker of 250 milliliter. And 2 test tube we are taking there. We are 5 milliliter of test tube we are taking, the same intensity of color gas in each tube there. And we are taking here the NO2. NO2 gas is prepared by which one? N2 gas is prepared by copper plus nitric acid. Okay. So we are actually producing NO2 gas by which one? By reacting with copper and HNO3. तो copper and HNO3 जो NO2 gas produce हो रहा था वो आपने टेस्ट ट्यूब में ले लिया, है ना. टेस्ट ट्यूब में लिया, कौन सा टेस्ट ट्यूब? 2 टेस्ट ट्यूब हमने ले लिया 5 मिलीलीटर वाले, और 250 मिलीलीटर बीकर आपने लिए. इसमें एक में रखा आइस कोल्ड कंडीशन, मीन्स यहाँ पे टेम्परेचर बहुत ही कम है 270 केल्विन. यहाँ पे आपने रखा नॉर्मल रूम टेम्परेचर, और यहाँ पे रखा वाटर एट 363 मीन्स यहाँ पे आप बॉइलिंग कंडीशन रखा. ठीक है. तो नाउ वी आर कमिंग हेयर, तो यहाँ पे फ्रीजिंग मिक्सर एक है, एक रूम टेम्परेचर है, एक हॉट वाटर है. हॉट वाटर मतलब जहाँ पे बॉइलिंग कंडीशन. सो बोथ द टेस्ट ट्यूब आर प्लेस्ड इन बीकर 2 मीन्स दिस वन रूम टेम्परेचर फॉर 8 to 10 minutes. After that, one is placed in beaker 1 and another is beaker 3. So one we are providing to where? Now providing to cold condition, but the freezing temperature. One is converted to which one? Now boiling condition. So in that reaction, what you have seen here, now it is exothermic in nature. So the heat is coming along with the product. ठीक है. तो if we providing the heat, तो क्या हो जाएगा? Now it will come back in backward direction. If we reducing the heat, so it will go in which direction? Forward direction. Clear now? So normal NO2, what is the color there? Now color is here intensity of brown color. Color intensity is brown in nature. We can see here the normal room temperature, so that is brown is coming, and when we are taking in the freezing condition, So when freezing condition means NO2 is converted into N2O4, that means brown color is reducing here. Okay, and here you can see the brown color is intensifying. Why brown color is intensifying? Because we are providing the heat. So when you are providing the heat, means this boiling condition, so then backward reaction is supporting there. Why? Because N2O4 plus heat. So if we providing the heat, so it will be coming in which direction? Backward direction. And if we reducing the heat, though, it will be coming in forward direction. So when it is coming to backward direction in the boiling temperature, that means NO2 gas is producing more from N2O4. So that's why the intensity of the brown color is increased here, and here intensity of the brown color decreased here. Why? Because of here we are providing the cold temperature, so NO2 is converted into N2O4. So जब NO2 N2O4 में convert हो जाएगा, brown color कम हो जाएगी, क्योंकि NO2 का ही brown color होता है. और जब मैंने temperature ज़्यादा कर दी, तो at that condition it is coming back to NO2, and so that the NO2 means it is brown color is intensifying here. So this is actually effect of temperature on any type of reaction which is reached at equilibrium. So if it is an exothermic reaction, so by increasing temperature it will support the or favor the backward direction reaction. Okay, next one we are coming for the catalyst. This is the catalyst one, effect of catalyst. Here also one more example is given to us, the temperature में, because blue color में convert हो जाएगा and pink color में convert हो जाएगा. So we can, this is an endothermic reaction. So if we are providing the heat, so it will be converted to blue color, and if we reducing the heat, it will be converted to pink color. Now we are coming for the effect of catalyst. जैसे first catalyst water, they are not taking part in reaction, rather they are actually catalyst lowers the activation energy. They lowers the activation energy. Okay, so this the temperature what we need or condition what we need, they are actually reducing the activation energy, so that in the less temperature also we can get the product. Just like example, the formation of NH3 from dinitrogen and dihydrogen, which is highly exothermic reaction and proceed with a decrease in total number of moles formed as compared to the reactants. Already you have seen that one. N2 plus 3H2 coming here 2 NH3. So 4 mole is converted into 2 mole there, है ना. तो यहाँ पे क्या बोल के रखा है कि इक्विलिब्रियम कांस्टेंट डिक्रीज विथ इंक्रीज इन टेम्परेचर. जितना आप इंक्रीज करोगे तो इक्विलिब्रियम कांस्टेंट क्या हो जाएगा? डिक्रीज हो जाएगा. एट लो टेम्परेचर रेट डिक्रीज एंड इट टेक्स लॉन्ग टाइम टू रीच द इक्विलिब्रियम. सो व्हेन वी कैन सी विदाउट कैटलिस्ट इफ यू आर रनिंग, so at that condition we can see as it is an exothermic in nature. So if we are providing the heat, so what will be happening there? Backward reaction will be providing. And if we are reducing the heat, the forward reaction will be taking place. But at low temperature, rate decreases and it takes long time to reach the equilibrium. Whereas high temperature give the satisfactory rates but poor yield. तो कंडीशन यहाँ पे ऐसे आ रहे कि हाई टेम्परेचर में रिजल्ट तो अच्छे आ रहे लेकिन यील्ड अच्छा नहीं आ रहे. तो एट दैट कंडीशन Fries Haver discovered that catalyst consisting of iron catalyze the reaction to occur at a satisfactory rate. So if we are using the catalyst that is actually iron, then it will be going in satisfactory rate at temperature, and where the equilibrium concentration of NH3 is reasonably favorable. Since the number of moles formed in the reaction is less than that of the reactant, so the yield of NH3 can be improved by increasing the pressure. So you can see here, जैसे reaction यहाँ पे है N2 plus 3H2, production is coming here which one? 2 NH3. So you can see here the moles are more here 3 and 4 और यहाँ पे 2 है. तो अगर जैसे direct moles are actually directly proportional to which one? Pressure also. तो if we increase the pressure, definitely it will go in forward direction. तो ज़्यादा से ज़्यादा amount of product आपको मिल जाएगा. And if we in case of we can say temperature है ना यहाँ पे, so as it is means moles are more here in the reactant and product moles are less, and that is an exothermic in reaction. So definitely if we are here plus energy you can say here, so exothermic in nature. So if we providing the more, we can see the pressure, so definitely it will be going on the forward reaction. So here it is coming that Optimum condition or temperature and pressure of the synthesis of NH3 using catalyst are around 500 degrees Celsius and 200 atmosphere. So in that condition they are actually working successfully. Here also some reactions are given to us. And now we are coming for the ionic equilibrium in solution. What is the ionic equilibrium actually? So on the basis of we can say the conductance of electricity increases with an increase in concentration of common salt, means it is coming ki some are electrolytes. Those are one category of substance that conduct electricity in their aqueous solution are called the electrolytes. One category of substance which can conduct electricity in their aqueous state is called the electrolytes. Some electrolyte are strong and some are weak. Who are strong here? Now those who are completely dissociating in their aqueous solution, they are called the strong electrolyte. Just example आप देख लो. Strong electrolytes on dissociation in water are ionized almost completely, while the weak electrolytes are only partially dissociated. For example, कौन सा सोडियम क्लोराइड अगर ले लोगे आप तो is comprised entirely of sodium ions and chloride ions, while that of acetic acid, CH3COOH, mainly contains the unionized acetic acid molecules. Only some acetate ions and hydronium ions are produced in there. So 100% ionization in case of sodium chloride and 5% ionization in case of acetic acid. So who is strong electrolyte here? Sodium chloride is a strong electrolyte here, and the weak electrolyte is the acetic acid here. So in case of it should be noted that in weak electrolytes equilibrium is established between ions and the unionized molecule. This type of equilibrium involving ions in aqueous solution is called the ionic equilibrium. जैसे example आप दे देते हैं कि NaCl जब dissociate होता है, it is completely dissociated into Na plus और Cl minus, so definitely unionized condition है ही नहीं इधर. तो इक्विलिब्रियम किस स्टेट के बीच रहेगा? अनआयोनाइज्ड एंड अनआयोनाइज्ड आयन के बीच. तो यहाँ पे उतना हमें इक्विलिब्रियम की कंसंट्रेशन हमें नहीं लेना है. बट व्हेन इट इज कमिंग अबाउट द एसिटिक एसिड और एनी वीक एसिड यू कैन से, so at that condition it is dissociated into which one? CH3COO minus, that is called acetate ion, and H plus. So at that condition it is not completely ionizing. Little bit amount is 5% we can say. If it is 100% ionized means total जितना NaCl ले उतना ही Na plus Cl minus हो गया. तो किस बात की इक्विलिब्रियम? और यहाँ पे क्या हो रहा है ना, 5% एसोसिएट, तो 95% क्या हो गया? CH3COH के फॉर्म में ही रह गया. तो दैट्स व्हाई इट इज कॉल्ड नॉन आयोनाइज्ड पार्ट, दिस इज कॉल्ड आयोनाइज्ड पार्ट. सो in that condition we are maintaining the equilibrium at the, you can say this is called actually ionic equilibrium, means where in case of weak electrolyte, those one are completely dissociating, so some amount remain as undissociated parts, some are dissociated parts. So that equilibrium, the equilibrium between the dissociated and undissociated, that is called ionic equilibrium. So next we'll discuss about the ionic equilibrium. Okay.